We were discussing the convex lens. Okay, we were discussing the convex lens, and
Yes.
in the last class, we discussed what is the focus of the convex lens,
Yeah.
what is the focus of the concave lens. Okay,
Yes.
and after that, I told you in the last class that what is the focal plane. Okay, so today we'll discuss the rules for the image formation by the convex lens. So the meaning of this means why we are studying this. Uh, this is a convex lens. So rules means what will happen when a ray of light will pass from a lens with different angle of incidence. With different incidence, what will happen? That is basically the rules for the image formation. You will understand in 1 minute. For example, if this is the optical center, okay, this point I am supposing as the optical center O. O is the optical center. O is the optical center. Now, if suppose there is a ray of light, if a ray of light is passing from the optical center, it will pass straight. There will be no deviation.
Yes.
This is the first rule. There will be no deviation. Earlier also we discussed about the optical center. If
Yeah.
a ray of light is passing from the optical center, it will pass straight. There will be no deviation. Now, second rule. Okay, suppose if a ray of light is parallel to the principal axis like this. If a ray of light is parallel to the principal axis like this, and this is passing from the convex lens, this is a convex lens.
Yeah.
So always after passing from the convex lens, it will pass from the focus. Okay,
Mm.
so this point on the principal axis will be the focus of the convex lens.
Okay.
Now, third rule. If a ray of light, I told you that in case of lens, there are two foci. There are two focuses, or foci you can say. In
Mm.
case of lens, there are two focuses. Now, if a ray of light, this is the first focus, F1. If a ray of light is like this, passing from the first focus, and after passing from the first focus, it is striking on the lens like this. So after passing from the lens, na, it will become parallel to the principal axis. It will
Mm. Okay.
become parallel to the principal axis. Now this is the principal axis.
Yes.
So basically, these are the three rules, and we will only use two rules, this one and this one, for the image formation for the convex lens. So we will place object at different positions in front of the convex lens, and we will see what type of image will be formed: real, inverted, virtual, erect, larger than the object, or smaller than the object. We will see different types of images. Okay, now we will discuss the image formation. So first, just take the screenshot, and just remember, if a ray of light is passing from the optical center, it will pass straight.
Yes.
If a ray of light is parallel to the principal axis, it will pass from the focus.
Focus.
After refraction from the lens, you can say, or after passing from the lens, you can say.
Okay.
Or third rule, if you want to learn, uh, if a ray of light is passing from the focus, after passing from the lens, it will become parallel to the principal axis. So take one by one, take the screenshot. Then we will discuss the image formation by the convex lens.
Done.
Sorry.
Done.
Okay.
Done. Done.
Okay. Now we will discuss the image formation by the convex lens. So this is a convex lens, and I told you that in our syllabus we have very thin lenses. We have very thin lenses. Okay.
Yes.
And this is a convex lens. This is the principal axis. Okay. This is the principal axis. Okay.
Yeah.
So now we will discuss the image formation. I am marking the focuses. This is suppose f1, and this is 2f1. This is f2. This is 2f2. And this is the optical center. This is the optical center. Okay. So case number 1, I am taking case number 1. So what is case number 1? So case number 1 is we will place the object beyond 2f1. Just a minute. Beyond 2f1. Okay, now it's okay now? It's okay. So beyond 2f1 we will place the object and we will see where the image will form.
Okay.
Okay, so I am taking one object and placing beyond 2f1. So the object is here beyond 2f1.
Yeah.
Like this. This is the object. Now we will draw the ray diagram, and with the help of the ray diagram we will get where the image will form. Okay. So this is the object. So now I told you in case of the mirrors also, for the image formation at least 2 rays from the object must be refracted or reflected.
Yes.
Okay.
Okay.
So now we will take 2 rays. So first ray from the object I will take like this, parallel to the principal axis. First ray from the object parallel to the principal axis. And I told you that what happens when a ray of light is parallel to the principal axis, after passing from the lens it will pass from the focus.
The focus. Yeah.
It will pass from the focus. Suppose like this. Another ray from the object I am taking like this. Okay.
Okay.
I told you that if a ray of light is passing from the optical center, it will pass straight down. You can see second ray I have taken like this, and it is passing from the
Center.
optical center. Okay.
Optical.
And it will pass straight, and where the 2 rays are meeting will be
Yes.
the image there.
Yeah.
So here the image will form, and this image will be something like this.
Yes.
This will be the image. Okay, this is the image. Now, tell me, here these rays are actually meeting, or just here we are just uh, here these rays are actually meeting, these rays are actually meeting or appearing to meet?
The meeting.
Hmm. If they are actually meeting, then which type of image will form? Real or
Real and
virtual? Real
real and
image.
yeah, real.
Real and inverted also, you can say.
Yeah,
Real
real
image is
and
always
yeah.
inverted. And you
Yes.
can say inverted with the help of the ray diagram. See
Mm,
the
okay.
arrow, upward arrow and downward arrow. Or
Yeah.
you can say this is above the principal axis, below the principal axis. So what type of
Yeah.
image is? Real and inverted.
Real and
Clear?
inverted. Yeah.
Inverted. And now
Yes.
talking about the position. What is the position of the image between F2 and 2F2?
Yes.
Okay. Now tell me the size of the image. Size of the image is greater than the object or less than the object? You can
Less than the
less
object.
than the object. Very good. Okay. Now
Okay.
it's fine.
Yeah.
Means so you can say image is number one. Nature of the image is real and inverted.
Yes.
Real and inverted. If someone is asking why real and inverted, then you can say rays are actually meeting.
Yes.
Okay.
Okay.
First, we will describe the position. After that, we will discuss the position of the image is between F2 and 2F2, formed between in examination. Draw the ray diagram with the help of a scale
Okay.
and pencil. F2 and 2F2. Formed between F2 and 2F2 and images real and inverted. Okay. And it is smaller in size than object. The other name of smaller than object is known as the diminished image. Diminished.
Okay.
Okay, so diminished image is what is the meaning of diminished? Smaller than object. Image is smaller than object.
Yeah.
This is case number one. And the case number one is object beyond 2F2. Now we will place this object, no? This object we will place here at 2F1.
2F. Okay.
Okay. We will place the object now at 2F1, case number second. Hmm. We will place the object at 2F1. So this is the object. This is the object at 2F1. Now we will draw the ray diagram again. So first ray from the object is parallel to the principal axis like this,
Yes.
and after refraction from the lens it will pass from the focus. It will pass from the focus.
Focus. Yeah.
Hmm. Like this. Another ray from the object from the object is passing from the optical center like this, and it will be like this. So means image is forming somewhere here at 2f1. Okay,
Okay.
image is forming at 2f2, not at 2f1. It is
Mm,
forming
mm,
here, but in actual it will form here. Okay, so we can just
okay.
shift it like this. Okay, here the image is forming at this point. So this point will be 2f2. Here the image is forming. This is the image. Here also the rays are actually meeting. Here also the rays are actually meeting means,
Yeah.
and you can see the arrow direction. So image will be real and inverted. Now what is the position of the image? At 2f2,
Yes.
and size almost same,
Almost same.
means size will be same here. In this case, the size of the object and the image will be same in this case. You can see. So you can write images formed at images formed. You can write at 2f2. It will be real and inverted.
Yes.
And what about the size? You will say same size as object.
Yes.
Okay, now this object I will place between f1 and 2f1 here. Okay, then we will see where the image will form. Case number third. When you will mark f1 to f1,
Yes, sir.
okay, f2 and 2f2. So basically, the distance between the optical center and f1 is same as the distance between f1 and 2f1. In the same way,
Okay.
the distance between optical center and f1 is same, means this distance, this distance, this distance, this distance, all are same.
Okay. So,
Now we will place the object between 2f1 and f1, and we will see where the image will form. So I am placing the object here. We will draw the ray diagram now again. First ray from the object is parallel to the principal axis like this,
yes.
and after passing from the lens or after refraction from the lens, it will pass from the focus. Okay, it will pass from the focus like this. Another ray from the object is passing from the optical center like this. Okay, and here some, and when the ray passing from the optical center, it will pass straight. So you can say, you can see second ray is passing straight,
Yeah.
and both the rays are meeting here after refraction from the lens. So here the image will form. So here the image will form. Now what can you say about the image? Image is forming beyond 2f2,
Yeah.
real and inverted,
Yes.
and size of the image is greater than the size of the object.
Yeah. Correct.
Hmm.
It's virtual and inverted.
No. It is not virtual and it is real and inverted because
Okay, real and
rays
inverted.
are
Yeah.
actually meeting and it is
Yes.
inverted.
Yes.
You can say, see,
Yes.
direction of the arrow here, or this is above the principal axis, this is below principal axis. In this way, you can see.
Yeah. Okay.
So you will say image is number one formed beyond 2f2, formed beyond 2f2. Number
Yeah.
second, real and inverted. Number third, larger than the object. And second name of larger than the object is magnified.
Yeah.
So it will be magnified. Okay. So now I will place the object at focus here, F1. Okay. Case number, it will be case, this is case number third. Case number fourth we will discuss. We will place the object at focus. This is the case number third, object between 2f1 and f1. Okay. This is the object placed at focus.
Yeah. Focus.
Always remember one point. If the object is at focus, image will be formed at infinity. Always.
Okay.
Whenever the object will be at focus, in case of the mirror or in case of the lens, remember, if the object is at focus, image will form at infinity. If the object will be at infinity, then image will form at focus. Okay.
Okay.
So first ray from the object is like this, parallel to the principal axis. And after passing from the lens, it will pass from the focus, second
Yes.
focus.
Yeah.
Okay. Now another ray is like this. Now you can see both these rays are parallel. These rays are the parallel rays.
Yeah.
And parallel rays where the parallel rays meet at infinity. At infinity, the parallel rays
Yeah.
meet. So where the rays will meet, the image will be formed there. Here the rays are meeting at infinity, where the image will form at infinity.
Yes.
So image will form at infinity. Okay, image will be real and inverted, and the size of the image is much larger than the size of the object. So you can write images number one formed at infinity. Okay, number second, Number second, real and inverted. Number third, much larger than object.
Mm.
Now case number fifth. We will place now this object between the optical center and F1. Case number fifth. We will place object here. This is the object. Now we'll draw the ray diagram again. First ray is parallel to the principal axis. After refraction from the lens, it will pass from the focus. Okay, like this. Another ray from the object is passing from the optical center and will pass straight.
Mm.
Now you can see here both these rays are diverging in nature,
Yes.
and these rays will never meet in reality. So what we
Yeah.
will do, if these rays will never meet,
Reduce backwards.
we will produce backward. If these rays will never meet, so it means that there will be no image. No, there will be image, but the image will be virtual, not real, because we will produce these rays in the backward direction, and where these rays will meet in the backward direction, there the image will form.
Form. Yeah.
So I am producing these rays in the backward direction, and where these rays will meet, there will be the image. So I think somewhere here these rays will meet. So here you will get the image. So now you are getting the image on the same side of object.
Yeah.
Okay.
Okay.
So if someone is asking where the image will form, so you will not say that image is forming between F1 and 2F1. This image can form beyond 2F1 also. This
Okay.
image can form here also, here also.
Okay.
But we will say here the image is forming on the same side as object. Where the object is present, image is also present on that side.
Okay.
And now you can see these rays are actually meeting or just appearing to meet.
Appearing to meet.
Appearing to meet. So image will be virtual and erect.
Yeah.
Position of the image same side as object. And what about the size? Larger than the object. Image is larger than object. Okay. So we can say number one, image is number one formed on same side as object. Number second, we can say virtual and erect.
Yeah.
Number third, what can we say? Number third, larger than the object. Ziyad, we will wait for Azan
Okay,
for 1 minute, okay?
okay.
Okay, so we have placed the object here and we are getting virtual and erect image, and size of the image is larger than the object we are
Yes.
getting. This is the only case where you will get the virtual and the erect image. Otherwise, always you will get the real and inverted, real and inverted, real and inverted, real and inverted. Okay. So this is the case number 5. When you are placing the object between F1 and the optical center, you will get the virtual image. So
Okay. Okay.
object between optical center and F1. Okay, now we have one more case. We will place the object at infinity. And I told you, whenever the object will be at infinity, the image will form that focus.
Yeah.
Case number 6. So if the object will be at infinity, and always remember, rays from that object will be always parallel. If the object will be at infinity, the rays from that object will always parallel. So these are the rays from the object at infinity, parallel rays. So these rays are parallel rays.
Yeah.
Now I told you that if a ray of light is parallel to the principal axis, for this ray I am talking, this ray is parallel to the principal axis. After passing from the lens, it will pass from the focus. Okay.
Okay.
Like this. Another ray also pass from focus, like this.
Okay.
So where both the rays are meeting at focus, so image will form at
Hmm.
focus. Okay.
Okay.
So image will be real and inverted because rays are meeting actually, and it is inverted also. And size of the image will be very, very small.
Right.
Size of the image will be very, very small. It will be real and inverted, and position at focus. So image is number one, formed at F2. F2 means principal focus. We discussed now what is principal focus.
Yeah.
Second focus is the principal focus. Okay. So formed at F2. Number second, it will be real and inverted. Number third, point size image. Means very, very smaller than object. So this is the image formation by the convex lens. We have covered all the cases. This is the case number fifth, object at infinity. Object at infinity. Rays from the object at infinity will always be parallel. So one by one, take the screenshots, and then we will discuss the image formation by the concave lens. Hmm.
Done. 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 Yeah, done. 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 Yeah, done.
Okay. So now we will discuss the image formation by the concave lens, and you can see this convex lens is converging in nature. All the rays are getting converged. You can see rays are getting converged. But in case of the concave lens is diverging in nature. Means rays coming, passing from the concave lens, getting diverged. So accordingly, the image will form. So first we will discuss the rules for the image formation by the concave lens. So three rules are there. Number one, this is the optical center. Okay,
Okay.
this is the optical center, and this lens is very thin lens. Okay,
Okay.
this lens is very thin lens. Okay. So if a ray of light is passing from the optical center of a concave lens, it will pass straight. Rule number one. This is the principal axis. Another rule, rule number second. If a ray of light is parallel to the principal axis, like this,
Yeah.
after pass, and I told you that uh, if this ray of light is parallel, then this ray of light is parallel
Yeah.
like this, parallel to the principal axis.
Yes.
Now, concave lens is diverging in nature, so it will be this ray will be diverged like this. And when you will produce this diverged rays in the backward direction,
Mm-mm.
when you will produce this diverged ray in the backward direction, so this will appear to meet at F2 at the focus of the concave lens. Okay.
Okay.
Third rule. Third rule. This is F2 and this is F1. If a ray of light is going towards F2, like this, going towards F2.
Yeah.
So towards F2 means it will be like this. So if this ray of light, is going towards F2, after passing from the lens, it will become parallel to the principal axis.
Okay.
So these are the three rules in case of the concave lens. So copy this.
Done. Done. Done.
Okay. So now we will discuss the image formation by the concave lens. Image formation by the concave lens. So in case of concave lens, there are only two cases. There are only two cases for the image formation. First case is if you will place the object at any position except infinity. In front of the lens, you can place the object anywhere except infinity. So I am placing the object here. So this is the object. So I have already written, saving the time.
Okay.
This is the object. And first ray from the object parallel to the principal axis. After passing from the lens, what will happen? It will get diverged, and when you will produce the diverging ray in the backward direction,
Yes.
so it will meet at focus.
Yeah.
So means somewhere here it will meet. Now another ray from the object I'm taking like this, passing from the optical center, and it will pass straight. Somewhere here the image will form. Here the image is formed between the optical center and the focus.
Okay.
The image is forming. So basically, this is not that accurate, but this is the object. This is the image.
Okay.
I for image. So this image is forms on the same side of that object. So image is forming on the same side of that object. You can see here. On both are on the left hand side. Virtual and erect, because rays are not actually meeting. We have produced this ray. That is why this image is virtual and erect.
Yeah.
Diminished means smaller in size. So this image will be smaller in size as compared to the object. Another case, in case of the concave lens, is this. When you are placing the object at infinity.
Yes.
Object at infinity. So I told you, if the object at infinity, where the image will form? At focus.
Yeah.
So this is the ray diagram from the object at infinity. I told you the rays will always be parallel. So these are the parallel rays coming, and after passing from the lens, getting diverged. And when you will produce these diverging rays in the backward direction, these rays will meet at the focus, and here the image will form. And this image will be virtual and erect.
Yeah.
Why virtual? Because rays are not actually meeting.
Yeah.
These rays are just appearing to meet here
Yes.
at F2. And what is the location of the image? At F2. And what is the size of the image? Very, very
Very
smaller
small.
than the object.
Yeah.
So image is formed at focus. It is virtual and erect, and it is point size. Point size means much smaller than object.
Yeah.
Much smaller than object. Okay. So this is the, and one thing you noticed here, you can see in case of this concave lens, image forming is always virtual and erect.
Yeah.
Two cases are there,
Yes.
and image is always virtual and erect. And you can see the size of the image. Diminished means smaller than object. Here also is smaller than object. So you can note one point. Concave lens forms image always virtual and erect, virtual and erect, and diminished, or you can write and smaller than object. Okay, so now
Okay.
Can copy this.
Done, sir. Done, sir. Done, sir.
We will have lens makers formula. Lens makers formula. Suppose this is a lens
Yes.
and this is the principal axis and this lens. NL is the refractive index of the lens.
Okay.
Do you know now refractive index? We discussed earlier refractive index.
Yes.
Different medium have different refractive index.
Yes, sir.
So suppose this lens has the refractive index of NL, and surrounding the lens there is a medium having the refractive index of N suffix M.
Okay.
And R1 and R2 are the radius of the curvature of the
Yeah.
surfaces of the lens. Okay.
Okay, sir.
So R1 and R2 also you can do. And F is the focal length of this lens. So R1 and R2 are radius of curvature. Radius of if this much data is given to you, then you can find the focal length of the lens easily with this formula, lens maker formula. 1 upon F is equal to refractive index of the lens divided by the refractive index of the surrounded medium minus 1 multiplied by 1 upon R1 minus 1 upon
Art.
R2. R1 and R2. Okay, so we will discuss one question. We will discuss one question. Okay, so this is the question, and in this question, R1 is equal to R2, that is equal to 10 centimeter is given. Okay,
Okay.
I'm removing this because this will not be given to you in the question. Only data that will be given in the question will be this length, and nothing will be given to you except this data. So accordingly, we will solve the question. So only this data will be given. A length will be given to you like this. This length
Yeah.
will be given to you, and R1 and R2. R1 means the radius of curvature of this surface, R1, and R2 is the radius of curvature of this surface. Will be given, and both are equal to the 10 centimeter. NL, refractive index of the lens medium, will be given.
Okay.
And length is kept in air. So this information is given to you, and you have to find the focal length of the lens. Okay. So to find the focal length, if radius of curvature and refractive index is given, we have lens maker formula 1 upon F. Okay, so this formula we have. So what we will do here, na sign convention is important. Okay,
Yeah.
if suppose for this surface the radius of curvature is R1, and for this surface The radius of curvature is R2 and object is placed here. And if the object is placed here, so light from the object will be in this direction like this. Object will give light like this now.
Yeah.
So this is the incident light. Incident ray. And direction of the incident ray is considered as positive in sign convention. Okay.
Okay.
So direction of the incident ray is considered as positive. So this direction we will take and positive, and opposite of this direction we will take negative. What is the meaning of this statement? I want to say that if you will measure the distance in this direction, that will be taken as positive. If you will measure the distance in the opposite direction of this, that will be considered as negative. Okay, so
Okay.
now what is R1? So R1 is for this surface. For this surface, there is R1. So now we will see what is R1. If I am talking about R1, R1 means like this. Here will be suppose this the center of curvature 1. There will be the center of curvature for this surface, for the first surface, and the distance, this distance will be radius of curvature R1. So R1 you are measuring in this direction.
Yeah.
In this direction you are measuring R1, and this direction is taken as positive, means your R1 will be positive. R1 will be plus 10 centimeter.
Yeah.
Now
Yeah.
R2 will be minus 10 centimeter automatically.
Yes.
Because R2 you will measure, if suppose this is center of curvature C2, then your R2 will be this. You will measure R2 like this, from this surface to this. This will be your R2.
Yeah.
And R2 you will take negative by, because you are measuring R2 in the opposite direction of the incident ray. That is why R2 you will take negative. Now
Okay.
refractive index of the lens is given 1.5. What is the refractive index of the surrounding medium? So what is the surrounding medium here? Air. Air is the surrounding medium.
Yeah.
Lens is kept in air. So for air, the refractive index is 1. Now apply the lens maker formula. 1 upon focal length is equal to refractive index of the lens divided by refractive index of the surrounding medium minus 1. Okay.
Okay.
Multiplied by 1 upon R1 minus 1 upon R2. Now put all the values in this formula and you will get the focal length. So it will be 1 by f, that is equal to refractive index of the lens 1.5, refractive index of the surrounding medium is 1, and here is minus 1, and 1 upon R1 means 1 upon plus 10, or plus 10 can be written as 10. It will be minus 1 upon R2, minus of minus 1 by 10. Okay. So it will be 1 by f, that is equal to, this will be 1.5 minus 1 will be 0.5 and divide by 1, and this is multiplied by, this is 1 by 10 and plus 1 by 10, 1 by 10 plus 1 by 10 will be 2 by 10, means 1 by 5.
Yeah.
It will be 2 by 10 now. You can write like this. This is bracket here, so 1 by 10, and this is minus minus plus 1 by 10. And what is 1 by 10 plus 1 by 10? 10 LCM, and 1 and 1 2, so it will be 1 by 5 now.
Yes.
So it will be 1 by f is equal to 0.5 multiplied by 1 by 5. Now you can, okay, it will be It will be 50 by 5. Focal length will be 50 by 5. What is 50 by 5?
10.
10 centimeter.
Yeah.
So 10 centimeter will be the focal length of the lens. Write down.
Done. Done. Done.
Okay. After this, we will have magnification. Of lens. So in case of lens, we have the magnification. So magnification of lens is represented by m, small m, and this small m is given by height of image divided by height of object. Is equal to height of image divided by height of object, and this is also equal to position of the image divided by position of object. Okay, so there are two cases. Case number one, when the magnification of the lens is positive. So if the magnification of the lens is positive,
Yeah.
now compare with height of the image by height of the object. Means either sine of height of the image and height of the object should be negative, or either it will be positive. Means you can say sine of hi and ho are same.
Okay.
Are same. So what is the meaning of sine same? If suppose this is the principal axis
Yeah.
and an object is placed here like this. This is the object, and this object have height of the object. If I will take, then height of the object I will take positive, because this is above the principal axis. So height of the object is positive, then we are saying sine of height of object and height of image should be same. Means if HO is positive, then height of the image should also be positive. So height, if the height of the image is positive, means image is above principal axis, something like this.
Okay.
So this is the image. Now this image is erect, and erect image is virtual. So if the magnification is positive, then you can say the conclusion is, then you can say image is virtual and erect. Image is virtual
And
and erect. Now case number second, if magnification is negative. When magnification is equal to negative. Magnification negative means, suppose this is the principal axis. Okay. Now if the magnification is negative, and what is the formula for the magnification? Height of the image divided by height of the object. If m is negative, then sign of hi and ho should be opposite sign. Okay.
okay, sir.
Then only the m will be negative. Simple maths. So sign of hi and ho are opposite. If they are opposite, so what is the meaning of that? If the object is like this, so height of the object you will take positive.
Yeah.
So height of the image will be like this, because it should have the opposite sign. So this is the image, and height of the image you will take negative. Now both have the opposite sign. So this image is inverted now. So inverted image is real also. Then if the magnification is negative, then what can you conclude? Image is real and inverted. Image is real and inverted. Okay, now there is one question. This is the question. Find position, size, nature of image formed by convex lens of focal length 10 centimeter when a 2 centimeter long object is kept in front of the lens at a distance of 15 centimeter. Okay. So there is a convex lens. Okay. This is the convex lens,
Yeah.
and this is the principal axis, and an object is placed in front of the lens at a distance of given in the question. This is the object. Find the position, size, nature of the image formed by the convex lens. Focal length of the lens is given as 10 centimeter. So the focal length of a convex lens is always positive, and focal length of a concave lens is negative. So note this point. Focal length will be positive for the convex lens.
Okay.
An object, when an 2 centimeter long object, so the height of this object is 2 centimeter long,
Yeah.
and this is placed at a distance of 15 centimeter from the lens. So from the lens, this object is placed at a distance of 15 centimeter.
Yeah.
So this distance is 15 centimeter. Okay, this distance is 15 centimeter. Now,
Yeah.
what is given in the question? First, the focal length of the lens is given. Another, height of the object is given.
Yes.
This is the object. Height of the object is given. What is the height of the object? 2 centimeter. So we will take height of the object plus 2 centimeter. Why? Because this is above the principal axis.
Yeah.
Above the principal axis. Now,
Yes.
object distance, you will take negative or you will take positive? 15 centimeter, you will take negative or
Negative.
positive?
Negative.
Negative. Why? Because the object will give light in this direction.
Yeah.
This will be the incident ray.
Yes.
This will be the incident ray direction. So this direction will be considered as positive, and this direction in which you are measuring the object distance will be taken as negative. So that is why object distance given taken as negative, that is minus 15 centimeter. Now we have this much information and we have to find the position of the image, size of the image and nature of the image. Position means V.
Okay.
V is the position of the image. Size means height of the image. Nature means whether the image is real or virtual.
Virtual.
So this we can find with the help of the lens formula. We have the lens formula. One upon focal length of the lens is equal to 1 upon position of the image minus 1 upon object distance. Okay, what is V? V is the image distance, you can say.
Yeah.
Distance of image from the optical center, image distance.
Okay.
Now put the value. 1 upon focal length is given. Focal length is given as 10. So you will put
Yeah.
1 upon 10. This 1 upon V you will find, means you have to find, is 1 upon U. U is given as minus 15 centimeter. Okay, minus 15 centimeter. So from here you can find value of V. So it will be 1 by 10 and this will be minus minus plus. So it will be here minus. So it will be
Yeah.
1 by 15. So this is just a simple calculation you can do. So you will take the LCM 30. So 10, 3 the 30
Yeah.
and 15 to the. So it will become 1 by 30. So the image distance you will get plus 30 centimeter. Plus 30 centimeter means in this direction the image will form. Somewhere here there the image will be here, somewhere here.
Yeah.
Why I am saying here? Because you will measure this distance in this direction.
Yeah.
30 centimeter.
Yes.
This is the object, this will be the image. Here will be the image. Somewhere here will be the image. Now there is one formula of magnification. Magnification is equal to height of the image divided by height of the object, and this is also equal to V by U. So we can find magnification. So magnification, we have V and we have U. So what is V? V is plus 30 and you can see U is minus 15. So magnification will be minus 2. So now you can see here magnification is negative. And what was the conclusion? For magnification negative, image is real and inverted. I told you now.
Yeah.
Image is real and inverted. If the magnification is negative. After that, height of the image, how can we calculate? We can calculate height of the image with this formula. We have the magnification, and magnification is height of image divided by height of object. Magnification is -2. You can see magnification is -2. Now
Yes.
height of image. Height of image we want to find, and height of object is 2 centimeter given. Height of object 2 centimeter is given. Now from here you can find height of image. So height of the image you will get -4 centimeter. Height of image you will get 2 to the 4.
Yeah.
And minus also
Yes.
-4 centimeter will be the height of image. So height of image, if I draw here, so the height of image will be like this. So this will be the image, and this height of the image will be 4 centimeter. So in this way, you have to solve the question. Now you have find it the position of the image. Position of the image is 30 centimeter towards the right of length.
Yeah.
Size of the image is 4 centimeter, and nature of the image is real and inverted.
Inverted. Yes.
Real and inverted.
Yeah.
Okay, so okay, take the screenshot.
So can you remove this that this white bar is coming, sir, on the top?
What are you saying? Say again. What are you saying? Oh,
So this what? Yeah.
okay, sorry.
Yeah. I'm done. Done. Done.
Okay. Actually, Ziyad, I'm having some problem in my throat.
Oh.
So I am leaving you 8 minutes early today.
Okay, so no
Okay.
problem. Yeah.
And in the next class, we will discuss the simple microscope, compound microscope.
Yeah. Okay.
And basically, for the simple microscope, you should know the case of the convex lens when the object is placed between the optical center and focus. So that case you
Yeah.
should
Yes.
revise.
Yeah.
Okay. Tomorrow we will discuss that again, because simple microscope is nothing but that case.